Hello everyone, good afternoon and good morning, and welcome to today's webinar, Bridge and Culvert Rehabilitation Design Basics, which is the second of our exciting spring webinar series. Presenting today are Drew Wilms and Glenn Smith from Armtec, whom I'll introduce more shortly. My name is Janine Yetke. I'm the Director of Marketing, and my group runs Armtec's Drainage Solutions webinar program, and I'll be your host for today's event. As some of our regular attendees may have noticed, we are now offering our webinar through a new platform. With this change, we are excited to offer new functionality, including the ability to download brochures, project inquiry forms, and your CPD credit certificate right from your home screen. These documents can also be accessed through the menu at the bottom of the screen. We hope that you find these added features useful. We always look forward to questions, which we'll take at the end of the presentation, so please enter your questions into the question log at any time during the presentation. As a reminder, attending the session will qualify you for a 1-hour technical informal CPD credit. You can now download your certificate at the end of the presentation right from your home screen. For those who are attending as a group, please identify someone in the room to gather the required details and send the complete attendance list to drainage_webinar@armtec.com. Please note that the email address has changed. I will start off with a brief introduction to Armtec. We are one of Canada's oldest and largest infrastructure companies, supplying a full range of steel and HDPE-based bridge and culvert materials, as well as soil retention, stormwater management, and precast building systems. At Armtec, we provide solutions for a better world. We strive to be a leading provider of infrastructure solutions that deliver social, environmental, and economic benefits for an ever-changing world. We serve numerous sectors, from municipal to forestry and transportation to commercial, retail, and residential construction. More about how we service these sectors can be viewed on our website or through discussion with one of our experienced sales representatives. With our centralized engineering department and regional engineers, Armtec has the exceptional capability to fully support design and challenging engineered project requirements. Presenting today are Drew Wilms and Glenn Smith. Drew Wilms is the regional engineer for British Columbia and supports Armtec's full portfolio of stormwater management and engineered solutions, including bridge plate, multi-plate, and retaining wall products. Glenn Smith is a sales manager for the Atlantic region. With over 17 years of experience, he has been involved in the specification and installation of large-scale engineered products throughout the region. With that, I'll hand off this presentation to Drew. Welcome, Drew.
Great. Well, thanks very much, Janine. Thank you again to everyone for joining us today. We appreciate you taking a bit of time out of your busy schedules to join us for the presentation. So just a quick introduction or outline of what we'll be covering today. I'll give you a quick intro to rehabilitation concepts. We'll talk about essentially the pros and cons of relining or rehabilitation, when it's appropriate versus a full replacement. We'll then also consider the limitations to rehabilitation and when it would be required to do a full replacement. We'll go through some rehabilitation products. We'll go through an introduction to some corrugated steel pipe reline solutions, talk about our structural plate products as well. I'll go through some rehabilitation methods, and then I'll hand it over to Glenn to go through some fairly interesting case studies of some projects that we've done over the past couple of years. All right, so this is a quick introduction to really set the stage for what we're talking about today. There's going to be a significant demand for rehabilitation and replacement technologies over the next decade or so. More than half of Canada's infrastructure is actually more than 40 years old. So, approaching its service life or, essentially almost there, and a need for rehabilitation. As well, a third of Canada's municipal water infrastructure is also approaching its service life. So just to break that down into road and bridge infrastructure. So this graph was actually pulled from the Canadian Infrastructure Report Card from 2016. Essentially, there was a survey of numerous municipalities, ministries of transportation across Canada, and this was the result. So essentially, 25% approximately of the road and bridge infrastructure was rated from very poor to fair condition, essentially meaning that it's in either dire need of replacement or rehabilitation currently, or it will need to be replaced in the next 5 to 10 years. So that represents a massive investment in terms of infrastructure dollars, over and above $5 billion. So there's a lot of investment that needs to go into our infrastructure over the next decade. So just a quick comparison of rehabilitation versus replacement, and just to touch on really the key benefits of rehabilitation and why it might be good to consider this versus a full replacement. Of course, we have significant cost benefits, and we'll kind of talk about how that translates on a given project. But first and foremost, of course, we have little to no traffic disruption in a rehabilitation scenario. So we don't need to close the road. It's great for the end user. We don't need a detailed traffic management plan or anything like that. So it's great for a given municipality in order to minimize impact on the public. Secondly, of course, we have little to no, fill or excavation requirements, so we don't need to dig up the existing structure, particularly for, potentially buried culverts that may be under large amounts of fill. We've seen structure buried as deep as 15 to 30 meters. So in order to prevent excavation requirements for those systems, rehabilitation can be a great cost saver. We're saving on moving that material out and then also bringing in replacement, potentially well-graded granular backfill. We can also have fairly significant minimization of environmental impact, so we don't need to dig up any of those surfaces. We're not disturbing an existing aquatic environment as well. So there's no requirement really for detailed erosion or sediment control plans. Also, the design can be fairly simplified, translating into minimized design fees and all those sort of things as well. In terms of installation costs, rehabilitation is, significantly less expensive or costly than a full replacement. Generally speaking, we can typically, a rehabilitation might cost anywhere from 50 to 75% less than a full replacement. Of course, that's a general statement, but fairly significant cost savings because we have, faster installation times, very small crews required for a rehabilitation, smaller lifting equipment, all those sort of things as well. And I'll just jump to the last point there. Typically we have a much safer environment in a rehabilitation scenario as well versus replacement. Again, we have lighter machinery. We're also not working with large, open trenches or anything like that. So worker safety is definitely more compromised in a full replacement scenario. So just a few factors to consider, as an owner or a consultant, whether you're determining not to go with a rehabilitation system versus full replacement. Of course, the first thing to identify is what type of structure are we working with. Of course, if it's a 40-meter span precast bridge girder system or segmental bridge, the rehabilitation options that we're talking about today may not be suitable. If we're talking about buried structures or smaller bridges, that's when these technologies are really suitable. So that's, of course, something that needs to be identified up front. Secondly, we of course need to identify, the extent of the damage or distress. So why are we talking about, rehabilitation or replacement in the first place? So do we have significant deflections in the structure? Is there significant material loss or corrosion, as you can see in the photo on the right there? Is there cracking or spalling in a concrete system? Scour and piping for a backfilled structure is a very key thing to identify. If we have any loss of the backfill envelope, which is of course the soil support and really provides the capacity, the strength and the capacity of these culvert systems. If we have that material loss, rehabilitation may not be an option. So those are all things that need to be identified when we're doing an analysis of the culvert. Thirdly, hydraulics, of course, is a key consideration as well. So with any of the slip line or rehabilitation or relining products that we're talking about today, there's typically a reduction in end area of the structure. So of course we need to analyze the impact on the hydraulics and the conveyance capacity of these culverts. Oftentimes this is a cost benefits analysis. Is it worth being able to convey maybe only the 50-year storm versus the 100-year storm and having some overtopping of the road potentially one every 100 years in order to save potentially $300,000 on a given project. So that's something that of course needs to be analyzed as well. The cost benefits in terms of just impact on the aqueous environment as well. Lastly, site conditions, construction window, those are all things that need to be factored in if we're dealing with a sensitive fish environment or a fish window. Oftentimes a rehabilitation or a slip line can be done in a very quick fashion. We've seen installations as quick as 3 or 4 days. So if we have a tight timeline to get the installation done, we're often dealing with grant money or things of that nature. A rehabilitation option can be a great alternative to full replacement. So I'll just walk through a few rehabilitation techniques. Again, the focus of the presentation is going to be on relining. I'll just give you a very quick introduction to a couple more temporary solutions like shoring and then invert paving as well. So temporary shoring is, just as it sounds, it's a temporary measure. So essentially, if you've identified a structure that's, essentially near failure, or there's a significant concern about structural integrity, this is an option just to extend that service life an extra 1 or 2 years while you plan for, a temporary rehabilitation system or a full replacement. So again, it's just we might have some sort of shoring, jacking, whatever the case might be, just to ensure that we have a structure that continues to carry its load capacity. So if we have something like inverse curvature, as you can see in the bottom photo there, that's where we might see a concern, particularly with an existing buried structure. So invert paving is another somewhat temporary measure of extending the service life of a structure. So very common for existing structural plate pipe arches, where we see a lot of corrosion along the invert. Obviously the area of the culvert that's most subjected to the fluctuating water line. So essentially all we do with this type of system is put in reinforcing steel along the invert and along the haunches. You can tell we have a bit more concentrated steel, of course, where we have concentrated thrust loads, where we have tighter radii. So fairly simple system, potentially to extend the life of the culvert maybe 10, 15, or 20 years. Of course, this is counting on having still a stable backfill envelope, as well as a crown, or the crown of the structure that has to be in good shape as well. So no deflections or corrosion issues on the exterior as well. So just to translate that into a photo, you can tell we have all the rebar in the bottom of this structure concentrated at the haunches, and then we just pour concrete in the invert. All right, so relining is, again, as I said, really the focus of the presentation today. Just to talk a little bit about why reline is often can be a great solution for rehabilitation. Oftentimes we're dealing with structures, as you can see in the top right photo there, where a galvanized steel system was put in place, and it really shouldn't have been. Back in the day, we didn't have as great an understanding of the chemistry of the interaction between the steel and the aqueous environment in which it's installed. So that photo is actually taken from a project that we did on Hornby Road in Delta here in BC. So we have a very, a lot of organics, very acidic environment that this was installed in. Definitely not an area where we want to see galvanized steel installed. So we have a lot of coating technologies that have been developed. We have a much better understanding, and we're able to, very reasonably predict the expected service life of a structure now. Knowing, the pH, the chloride content, all those sort of things, we can design for, a 75 or 100-year service life. So relining, it typically involves a slip lining process. So a very simple installation procedure. Essentially all we're doing is sliding a coupled or a pre-assembled pipe liner into an existing pipe or the hose pipe. With that, we then typically utilize a bracing or blocking system to hold that structure in place, and that goes right in line with the third step here. So thirdly, we need to pump grout between the new structure and the existing structure to ensure that we have full load transfer from the existing or the hose pipe into the new one. So with that grouting procedure, we require bracing or blocking to make sure we don't have flotation as that process is undertaken. We also need to prevent any deflections throughout the system as we have the grout buildup up to the crown. So that third step is very important, that we have all the voids filled between the two structures. The annulus needs to be completely filled with grout, typically a low strength grout, generally speaking 28-day strength in the range of 1 to 5 MPa. So aside from the slip lining process, we do have a two-flange liner system that can actually be assembled in place. So we'll talk about kind of the differences in installation procedure between a slip line and a two-flange liner system. So just a few key advantages of relining, primarily in comparison to those other rehabilitation measures that we've spoken about. First and foremost, of course, we can restore the structural capacity of the culvert. So we can design for whatever the live loads are, dead loads as well. We can actually increase the load rating of the culvert as well. So if we're upgrading, from a service road to a municipal or a highway, or potentially if we're increasing the dead load or the extent of fill over the structure, we can accommodate that as well with a reline situation. Secondly, it allows for a means to widen the roadway, of course. So fairly simple, but we just basically extend the culvert, supply an extra length to add or allow for widening the roadway. Thirdly, at this point, we can nearly match the hydraulic capacity of the existing structure. So I talked about reducing the end area. So this is kind of on a case-by-case basis, and it depends what we're relining the structure with. But we do have smooth wall liners as well, which can help increase the efficiency of the culvert and reduce losses throughout the length of the system. So with that, we can oftentimes nearly match the capacity on a hydraulic level. Lastly, of course, we can extend or renew the service life, and again, without major capital expenditures. So this is a much more economical option versus a full replacement. Again, as we've talked about, it's kind of a cost-benefits analysis between hydraulic capacity loss and things like that. But typically, significant cost savings, and you get essentially a brand new structure that can have a service life anywhere from 75 to 100 years. All right, so just a quick introduction to Armtec's reline solutions. So there are quite a few of them. We do have plastic liner systems as well, so corrugated HDPE, that's our Boss 2000, really for small diameter relines up to about a meter in diameter. We have steel reinforced polyethylene pipe as well for larger round relines or rehabilitations up to 2 or 3 meters in diameter. So those can be great options. They have smooth inner walls, so again, minimizing hydraulic impact. Our focus today is really going to be on the metal liners. So I'll talk about our spiral rib corrugated steel pipe and then our 3 different types of structural plate options. So just an introduction to our spiral rib CSP. Armtec's trade name for this is UltraFlow. So I intentionally chose a fairly old photo just to highlight how long UltraFlow has been around and how long we've been actually rehabilitating structures with this technology. So UltraFlow is classified as a spiral rib CSP. So essentially, it's a little bit different than the kind of the sinusoidal corrugated steel that you're used to seeing. So the little corrugation profile is shown on the bottom left there. So we essentially have a box corrugation, 19 millimeters by 19 millimeters. So very shallow profile, meaning we have a very small difference between the inner and outer diameters. So again, with that translates into fairly minimal losses in terms of end area with a rehabilitation scenario. So the key benefit of UltraFlow is that we have a smooth inner wall. So it's a very hydraulically efficient pipe product. So Manning's N is 0.013 compared to a Manning's N of say 0.03 with your typical corrugated steel system. So in terms of sizes that UltraFlow is available in, we do have pipe arc shapes, and then we also have round shapes up to 2,600 millimeters in diameter. So this slide is just highlighting the coupling mechanism for UltraFlow. So instead of having an external coupler as we typically would with a new installation, we actually recommend having an internal coupler just to minimize impact on end area reduction. So it's basically a 2-piece coupling system, very simple. We just have a corrugated flat band bolted to each end of the 2 adjoining pipes. So the slide is just highlighting the typical procedure for slip line with any sort of pipe product. So this is applicable not just to UltraFlow, but really any type of commodity pipe round systems in a reline application. So as I said previously, we essentially just couple the 2 pipes together or more. We then have some sort of bracing or steel plate or timber blocking on the end of the structure just to allow pushing through with an excavator. So typically a very simple procedure. So once the pipe is in place, we then typically have screw jacks or blocks of some form to keep the pipe in place, again to prevent flotation during the grouting process. And of course that's the last step, so that's what's shown here in this next photo. So typically we're supplying UltraFlow and our other systems with either 2 or 3-inch threaded grout ports, so very easy to connect to with your typical grouting hoses and equipment. So next I'll talk about our structural plate solutions. So this is our multi-plate, bridge plate, and tunnel liner plate. So those are the three different types of structural plate that Armtec has to offer. So the key difference between these different types of structural plate, of course, is the corrugation profile as well as the steel thicknesses that they're available in. So multi-plate is really the original structural plate invented by Armtec back in the 1930s. So it's been around for a very long time. Of course, we've developed, of course, new types of structural plate since then. So bridge plate is a deeper corrugated system, allows us to design for much larger structures, as well as to design kind of unique shapes like box culverts, as it's able to carry, fairly significant bending moments as well. So tunnel liner plate, again, has a fairly shallow profile compared to bridge plate, more similar to multi-plate. But of course, it has a very unique geometry and corrugation profile in that we have a consistent outer diameter and we have a two-flange system. So we essentially have just bolted connections between adjoining plates along the length of the culvert. So very simple connection system. All of these are bolted type structures. But essentially, the key benefit of tunnel liner plate or any two-flange liner system is that it can be fully assembled from inside an existing conduit. You don't need access to both sides of the structure as you do with multi-plate and bridge plate. So in terms of design standards, we actually did a presentation at the end of last year on design procedures for these buried steel structures. So you can always go back and reference that. We won't talk about that too much in this presentation. But suffice it to say, we design multi-plate and bridge plate according to the CHBDC design code. So typical governing design factors are, of course, structure geometry, corrugation profile, of course, the loading conditions, so height of cover and vehicle live loads. Tunnel liner is actually designed according to the AASHTO standard specification for highway bridges. So there's no CSA standard that actually governs tunnel liner plate design. So in a reline application, these systems are designed, in the exact same manner as we do with a new installation. Of course, the key difference, though, is that we are not backfilling it with a well-graded granular material. So instead, of course, there's an additional check for grouting pressures. So very similar to checking for, the backfill loads or construction loads of a buried structure during installation or a new installation. We similarly need to check for grouting pressures at various states of the grouting process during installation. All right, so I'll talk about tunnel liner plate now. So it's a very versatile, customizable product. So this is just really highlighting the various shapes that we can achieve with tunnel liners. So by no means is that the full range of shapes or geometries that we can accomplish. So the diagram on the bottom left there is just showing the general plate layout. So we have 500 millimeter wide plates, typically about 1 meter to just under 1.5 meters in length in terms of the arc length. So essentially all we're doing is we're corrugating these plates and then we're curving them to whatever radius or radii are required to achieve a given shape and geometry. So there's really no limit in terms of what radius we can curve these plates to, and so thereby what shape we're able to achieve with the structures as well. So we can very easily match the shape of an existing structure for a reline application. So in the bottom right there, you can see again that corrugation profile that is also showing the typical grout port that we would shop weld at our facility in Guelph, Ontario. So again, it's a 2-inch threaded grout port, so very easily for the grouting, very simple grouting process. So a couple plate thicknesses available as well. In terms of weight of the plates, these are typically less than 100 pounds per plate, so very easily handled by 1 or 2 laborers on site. We do also have aluminum tunnel liner plates, so those are obviously much lighter. So if you have a site with difficult access or accessibility issues, those can be a great option for a lightweight alternative for ease of installation. So that's actually what's shown here on this slide is an aluminum tunnel liner plate installation, again rehabilitating an existing structural plate pipe arch. So you can see on the photo on the left there, the liner plate is being assembled fully from inside of an existing structure. So it makes it very easy when we're dealing with constrained sites if we don't have a large staging area for a slip line procedure. The photo on the right there is just showing the bracing that's typically recommended during the grouting process. So again, to prevent flotation, we need some form of blocking. We also want to make sure that the shape stays consistent or that the plate maintains its shape as we get the grouting over the crown of the structure. So this photo is just highlighting or showing again the grout port configuration. So typically spaced every 2 or 3 plates. Again, those are the 2 or 3 inch threaded grout ports. Just also wanted to highlight the different materials or coatings that we can supply with tunnel liner. So this is showing the crown or the haunch plates here are actually galvanized. And then we have a polymer coated plate system for the invert and footing plates. So fairly common there because we have the footing or invert plates are where obviously most subjected to the fluctuating water line. So those are obviously where we have the greatest concern with corrosion. So there are a few different coating and material types with tunnel liner, as I've mentioned. So we have galvanized steel, either standard or heavy galvanizing. Our StrataCat is the trade name for our polymer coated steel plate. So we've talked about that in other webinars, but really that's ideal for the most corrosive conditions where we have high acidity, alkaline conditions as well. And then we have aluminum structural plate, which can be a great way to extend the service life a little bit further than galvanized steel plate. And as I mentioned previously, it's a lightweight option for those difficult to access sites as well. So this slide is just highlighting the way we can customize the tunnel liner plate. So we can do open bottom structures. As you can see, we can fairly closely match the existing the profile of an existing structure. So we've also done near box shapes as well. So this is actually the photo on the top right there. Is a rehabilitation of some existing cast in place concrete boxes. So we can reline, fairly large structures with tunnel liner. So there are kind of 2 types of rehabilitation. One is a full structural rehabilitation as shown on the bottom right there. Typically, we're limited up to about 6 or 7 meters in span for a full structural reline, meaning that the tunnel liner is being designed to carry the full loading conditions. All the live loads and dead loads are transferred to that shell. Facial reline is actually where we have a much larger structure, and we're essentially designing it to prevent any further corrosion or deterioration of an existing structure. So that's what was shown. That's shown on the photo on the left here, where we have a very large elliptical super span. So it's about a 10-meter span structure. This is actually in Alberta along Highway 2. So the Ministry of Transportation there determined that it was needed, a facial reline was needed to prevent further deterioration of this structure. So as you can see, we were able to fairly closely match the geometry of that structure, essentially size it down so we have about 100 millimeters on each side between the existing structure and the new liner. So lastly, with tunnel liner plate, one of the key things to highlight is that we can also accommodate non-linear structures. So if you're dealing with a culvert, potentially it has a manufactured bend or an elbow, we can actually accommodate that with tunnel liners. So that's the unique property of this system. Obviously, with the slip line process, we can't actually accommodate any bends. So that's unique to the 2-punch liner system where we're assembling from inside of an existing structure. So whether it's a manufactured elbow, or a result of deflection over time of your existing culvert or bridge, this is something that can be accommodated with the tunnel liner plate. So next I'll talk about multi-plate and bridge plate, again in reline applications. So we've talked about tunnel liner plate. I mentioned that our maximum span in terms of a structural reline is about 6 or 7 meters. The same goes for multi-plate. We have essentially the same depth of corrugation, so the same strength and stiffness properties. The one time or the application where we might use multi-plate versus tunnel liner plate is where we have a culvert or a structure in which it may be unsafe to actually enter and assemble a liner from inside of that conduit. So if we want to have a kind of a safe installation, we might slip line it and actually grout it from outside of that structure so that the worker safety isn't compromised. Bridge plate, of course, is used for larger structures or structures where we might have a box culvert shape and we need to design for some bending. So oftentimes used for actually your conventional bridge rehabilitation, and then for larger, super span structures, structures up to about 20 or 22 meters in span. So this slide is just kind of highlighting, the wide breadth of applications where we've used multi-plate and bridge plate in rehabilitation scenarios. So this is actually an old wooden trestle bridge in Ontario, I believe owned by CN Rail. So we're able to actually rehabilitate this structure with 2 twin multi-plate rounds, I believe about 4 meters in diameter. So fairly simple installation, a fairly simple rehabilitation process. So a lot of money was saved going with this option instead of a full replacement. And of course, we were able to keep the rail line active, the CP rail, of course. So we were able to keep the rail line active during the rehabilitation procedure. Of course, at the end of the day, you can't even tell that there was an old trestle bridge in place there. So I'll just go through a quick example of slip lining with multi-plate, so essentially a full periphery structure. So this wouldn't vary really no matter what type of structural plate we're slip lining with. First step, of course, is dewatering or cleaning, so we need to remove all the material from inside of that structure, get it nice and clean. In this case, they unfortunately had cast-in-place fish baffles that they needed to jack out. Next step is to install rails or bracing, of course, just to facilitate the slip lining process and maintain alignment of the new structure inside of the existing. Next step, or in conjunction with step 2, is just to prepare a staging area, so an area in which we can actually assemble the structural plate, and of course that's the next step. So an iterative process in terms of assembly and slip lining. So with multi-plate, the plates they come in 10 and 12 foot lengths, so you might assemble 1 or 2 rings at a time, so anywhere from 10 to 24 feet in length at a time. So you essentially assemble those rings and then pull them into place, assemble the next rings, etc. So in terms of actually pulling the structure through, fairly simple. Usually we just recommend putting eye bolts through the bolts along the end of the structure, or the bolt holes along the end of the structure. So that's what the contractor did in this case. This was a 97-meter long pole. We had a structure under about 20 meters of fill. This is along Highway 97C, just outside of Kelowna here in BC. So this is a structure we rehabilitated in 2014. So it was just pulled through with an excavator. So fairly simple. You don't need a lot of heavy equipment to actually pull these structures through, even for fairly long culverts. Grouting is, of course, the next step. So, as I've reiterated, it's very key step in terms of having the new structure perform as designed. So we need to ensure that that grout is fully encapsulated and fill the voids between the host pipe and the new pipe. So it's important that we do some form of grout inspection, so we can supply these with inspection ports, or you can just drill a few small holes in the plate to ensure that the grout has reached a certain elevation along the structure's periphery. Lastly, of course, end treatments is an important consideration. Also a way that we can, minimize the hydraulic or the impact in the hydraulics of the system. So we can potentially do something to, minimize losses at the entrance of the structure. In this case, hydraulic capacity wasn't really too much of an issue. We also had a very low energy stream. So they just elected to go with a beveled end instead of a cast-in-place head wall or something of that nature. Okay, so now I'll go through a quick installation procedure with an arch structure and just kind of show how that varies compared to a structure with full periphery. So of course, we're dealing with footings, so we need to typically extend the footings out so that we allow for an area for the footing plates of the new bridge plate or the multi-plate structure to sit within. So this is an old concrete arch that we rehabilitated in Quebec for, I believe it's at Monk Linear Park. And this was done for the MTQ out there. So first step is to extend the footings. They actually installed a polyethylene liner along the invert of the footing just to help more easily pull the structure through the existing conduit. So next step, just as with the other one, we essentially pre-assemble a number of rings. The bridge plate actually has a plate width of 1.2 meters, so we can assemble 2 or 3 rings at a time. Drop them into place into the footing channel within our staging area, bolt along the circumference of the structure, and then pull them through 2 or 3 rings at a time. So this is just showing again the pull through, so very similar to what was done on the previous structure. We would actually install the bridge plate on an unbalanced steel channel, as you can see here. So that's what the structure was pulled through on, just a bolted connection along the crest of the corrugation. And then there's the finished structure. So they elected to put a cast-in-place head wall on the end here. Again, one of the best methods of actually protecting the structure from certain failure mechanisms like scour and piping and those sort of things. All right, so just one of the last things I wanted to touch on really are the design requirements for a rehabilitation or reline scenario. Armtec really wants to be involved from the ground floor, so in terms of developing a scenario or a solution, coming up with the geometry of a new structure, things like that. So a few key items that we need to know in order to come up with some design proposals. We need to know the required end area, so what kind of hydraulic capacity is required for the new structure. What kind of service life do we need to design for as well? So ideally, we'd like to know what the chemistry is of the existing water course and of the soil actually as well, if available, so that we can accurately design for a given service life. Thirdly, of course, very key, we need a condition report of the existing structure. So what are we dealing with in terms of alignment? What's the state of the backfill envelope as well, and what type of failure mechanism are we needing to address with this structure? And then, of course, we need load conditions to, design the new culvert or bridge for structural capacity, so live loads, dead loads, head of cover, all those sort of things need to be known. And then any other kind of specialized constraints that are a project-to-project basis need to be provided to us as well. All right, so that concludes my portion of the presentation. At this point, I will hand it off to Glenn Smith to take you through some case studies. On this slide, there's just a quick question. If you'd like to learn more about rehabilitation methods, solutions by Armtec as well, feel free to hit yes there if you'd like to arrange lunch and learn with one of our other regional engineers or a sales rep in your area. And at this point, I'll hand it over to Glenn Smith.
Thanks, Drew. Good afternoon, ladies and gentlemen. As mentioned, my name is Glenn Smith. I'm the sales manager for Atlantic Canada. I'm going to take you through some case studies depicting a wide range of rehabilitation projects we've created or completed throughout Canada. And I apologize, I have a little bit of a cold today, so if you can bear with me. So to begin, here's a multi-plate pipe arch under Highway 101 at Middleton, Nova Scotia, which had reached the end of its design life. The structure is 88.5 meters long and was in serious need of rehabilitation. It's a little hard to see on this photo, but there's something actually protruding up into the waterway at the other end of the structure. As you can see, this end was in much worse shape than the other end. The invert had corroded and began to protrude upward into the waterway. Nova Scotia Transportation and Infrastructure Renewal, who I'll refer to from now on as TIR, had installed some horizontal cross bracing at 3-meter centers to attempt to stop the structure from deforming any further. So myself and Randy McDonald, who is our engineering director, actually visited this site with TIR to evaluate the structure and provide our recommendation as to whether or not rehabilitation was even an option or if a full replacement was required. So after seeing the site, we suggested that a reline using our tunnel liner plate product would work. This was a very attractive option for the owner as the structure was under 8 meters of cover and a full replacement would be much more costly than the reline option. So for this particular site, our polymer-coated or Stratacat tunnel liner was used for the invert and haunch plates, while galvanized tunnel liner plate was used above the waterline. And here's the structure as it arrived at the TIR base in neat piles. The structure was easily transported from the TIR base to the site each day using a tag-along trailer hitched to a pickup truck. And once the first ring was completely assembled, successive plates and rings were connected until the entire structure had been assembled and torqued. So as shown here, no heavy lifting equipment was required to assemble the tunnel liner plate, as each segment is easily handled by one worker. Blocking was placed between the crown of the new tunnel liner plate and the host structure to prevent floating and movement of the structure during the grouting process. This installation was not a traditional one for Armtec, as instead of using flowable concrete grout, TIR decided to go with an expanding polymer foam to fill the annulus between the reline and the host structures. Using this method allowed the owner to grout the structure as it was being installed and without the need to construct bulkheads at either end to retain the grout material. Once we had the structure erected to the portion with the horizontal bracing, the structure was torqued and foamed. This provided a fully functioning structure behind the workers, which could have served for an escape tunnel had the structure began to move during construction. So before the first cross brace was removed, an additional brace was installed, making the spacing 1.5 meters on center. The cross brace was then removed and the old portion of the multiplate was cut out using a cut-off saw. The void was filled and the new liner plate was erected until the brace was reached. This process continued until the structure was completed. Here you can see the structure with the polymer foam in place. You can also see the blocking which was placed to prevent flotation and movement. You will see there's a considerable void at the crown of this structure. Of course, with a reline, the largest the new structure can be is smaller than the host pipe at its narrowest point. This structure had deformed considerably, and the size chosen was necessary to clear the host pipe at all points. The customer is responsible for providing the survey or sizing data which we will use to suggest the best possible shape to maintain the maximum amount of end area. And this here is a shot of the finished structure from the inside. Of course, this one was 88.5 meters long, so a fairly long installation. On the outside, TIR decided to place some grout at the ends to seal off the foam installation, which also provided a little more of an aesthetically pleasing effect. So next, in the fall of 2012, Armtec was asked by Public Works Canada to visit a site in Terra National Park in Newfoundland and assess the possibility of rehabilitating a 47-year-old structure, which was installed in 1965 using Armtec multiplate. At the site meeting, it was determined that the rehabilitation with tunnel liner plate would be the right solution, and aluminum plate was selected. Because of its location at the bottom of a steep embankment, accessibility to the existing structure was a challenge. The portability of the product made it a great solution for the unique geography of the product. And tunnel liner plate, which is only manufactured or only manufactures in Canada by Armtec, could be shipped to the site and hand carried in segments because they only weigh between 9 and 14 kilograms. These were brought through the structure just by hand. The alternative choice would have been to incur significant costs with building the access road to get down to the site. So essentially the work involved relining the existing 24-30 millimeter diameter multiplate, which was installed under 8 meters of cover, with a new 22-50 millimeter diameter aluminum tunnel liner plate. This structure was actually 43.5 meters long. During construction, the site was visited by a number of people such as engineering consultants, DOT engineers, public works engineers. Given the unique challenges posed by the project, there was tremendous interest in this solution, so much so that one of the workers actually said we should start charging a toll for people to come and look at it. So basically, as an overview of the project, there was a 10-inch pump that was placed at the upstream end, and water was pumped around the site, which allowed the multiplate to be dewatered. The existing multiplate had to be, of course, first cleaned of debris and rocks. Plates were placed in bundles at the upstream end of the structure using an excavator, and then were brought into the structure by hand by the crew. The crew of 3 assembled 5 plates inside the structure. The final top plate was then put into place to complete the first ring, and simple 2x4s was used as blocking to ensure uniform spacing and proper alignment of the reline pipe. The second ring was assembled with 5 plates and moved into place adjacent to the first ring. Once again, the final plate was placed into the top position. Each ring was bolted to the previous ring through an inward projecting vertical flange. This allowed the assembly, of course, to be completed completely inside the host pipe. And after only 3 days, the crew of 3 were able to complete 20 rings in a day. So once all the rings were fully assembled and the bolts were torqued, the specified torque on these were between 115 and 135 foot-pounds. The grouting was then completed using a portable concrete pump, and the grout mixture was freely flowing with an approximate 6-inch slump. Was placed in 3 uniform lifts along both sides of the pipe while ensuring the design diameter was maintained. Grout was injected through the grout ports, and then an ABS plug was placed in the port to retain the grout. And sandbags were placed on this one at the ends to prevent the grout from spilling out. So once completed, the ends were treated with a riprap and concrete wing walls against the beveled ends of the structure. The installation of Armtec's aluminum tunnel liner plate was a successful project for Public Works Canada here, and more importantly, there was little environmental impact to the area. So let's jump ahead 2 years. The Trans-Canada Highway above the original tunnel liner in Terra Nova required widening to create a new passing lane and improve the traffic flow through the park. So the existing tunnel liner plate was extended to accommodate the wider road. This shows the versatility of using a segmental structural plate for these applications. You can always extend the length at a further date if the need arises. So basically, we supplied an additional 14 meters of aluminum tunnel liner plate to extend the original reline. Given that this portion of the project was not a reline application, it was actual fact a traditional installation. The contractor was able to construct sub-assemblies and lower them into place with an excavator. The tunnel liner was then backfilled using well-graded granular engineered backfill material and compacted to 95% standard Proctor. Jumping back to Nova Scotia, here's a stone box shape which is under the Cape Breton Railway system. Due to concerns about corrosion or the condition of the structure, the Cape Breton Railway were looking to rehab this one. Our design team went to work, and we shortly after we were able to provide an option to the owner. So a tunnel liner plate was again selected, and a set of drawings were produced for the owner's consideration. For this railway application, we recommended a reinforced structural concrete grout. As you will see on following slides, our StrataCat coating was applied to the footing plates as the brackish water of the Bredor Lakes warranted extra protection from the elements. So here you can see the structural rebar has been placed prior to the assembly of the tunnel liner. And this is basically just another shot of the installation showing the contractor's staging area and staging. And as mentioned, our tunnel liner plate, of course, was installed without disruption to the rail traffic above. So this is the finished product. We managed to retain a portion of the original stonework while rehabilitating this structure and ensuring its structural stability for years to come. So after our successful installation with the Cape Breton Railway, they again asked us to assist them with another old stone box, which was in need of rehab. So measurements were taken and sent to our design team for analysis. The existing structure was a 3048 millimeter span by 2438 millimeter rise with severe spalling and reinforcement corrosion. 3 tunnel liner plate options were proposed to the owner for their perusal, each with different end areas and geometries. And the solution chosen was a 2790 millimeter span by 2420 millimeter rise aluminum tunnel liner plate. The length of this structure was actually 10 meters. The reinforcing steel was again placed between the host structure and the new liner plate, and then the void was injected with a non-shrink flowable grout through factory installed grout boards. In this photo you can see another one of our products which was implemented and used during the construction process. Our bin wall was used as a cofferdam on the upstream end with water being diverted through pipes during erection. So basically here's just a photo of what the contractor did. Is a photo of our bin wall cofferdam and the pumps. So as this was a railway application, the structure arrived on site using a rail truck. And then this structure was constructed using sub-assemblies, which were then lowered into place using the boom on the rail truck. And here's the finished product. Again, some of the original stonework was preserved on this one. This here was a nice project. It's a picture of a 100-plus-year-old cobblestone arch located in Barney Park, Newfoundland. We worked with a consulting firm in St. John's to recommend a solution for the city for rehabilitating this structure. Again, tunnel liner plate was selected, and the contractor did an excellent job of preserving the natural look of the old structure. So also our engineering group sometimes bring our drawings to life by inserting project pictures into the proposal to give the owners actual in-situ applications to consider. Back to Nova Scotia again. Here we have twin multi-plate pipe arches in Cape Breton Highlands National Park. They're 3890 millimeter span, 2690 millimeter rise, and 33.3 meters long. For this reline application, again, aluminum tunnel liner plate was chosen. Given this was a twin installation, the contractor was actually able to set up a cofferdam and completely divert the river through one structure while the other one was being worked on in the dry. Since the maximum individual weight of the aluminum tunnel liner plate was only 15 pounds in this case, the contractor was able to store the entire structure on a tag-along trailer and bring it home with him each evening. The lightweight also enabled, of course, the workers to install this without the use of heavy machinery. And here you can basically see just the simple wood blocking to keep the structure in alignment during the grouting process. Factory installed grout ports, of course, allowed the grout to be injected at specific intervals along the length of the structure. This reline also allowed the length of the original structures to be extended. And in the other photo, of course, you can see the concrete truck bringing the grout mixture to the pump. The selection tunnel liner plate for this project also allowed the owner to install fish baffles at regular intervals to control the flow rate of the stream to allow fish to pass safely through. Fish baffles actually in tunnel liner can be installed during construction or down the road if they're deemed necessary at a later date. So here's a shot of the completed project. And just out of curiosity, we're just wondering how many rehabilitation projects any of you guys may be planning for this year. I'll just pause for a moment there to give you a chance to make your selection on the screen. All right, we'll jump ahead as it's 23 minutes past. Okay, so basically here's a summary slide. It was 36.5% at 0, 42.3 1 to 2, 11.5 3 to 5, more than 5 or 9.6. So it's good. Shown here is a multi-plate reline on the Hanlon Expressway in Guelph, Ontario. As you can see in the photo, the contractor used wood to construct a staging area in front of the host structure. This also gave him the ability to raise the structure off the ground so we could get the bolts in the invert of this structure. Inside the host structure, the contractor poured some mass concrete and laid angle along the length to create a guide or a track for the new structure. They actually parked the tow truck at the other end of this and hooked the tow truck up to the slip lining pipe, the reline pipe, and pulled it through that way. This one is a shot from Alberta. They were replacing a conventional girder style bridge. We used 2 corrugated steel pipes and a bridge plate box culvert, and the finished end of this box culvert appears scalloped, but that's because it was actually cut on a skew to the road. So this is another railway underpass. Basically, it was a 3-span concrete arch bridge. The 2 outside spans were over 11.3 meters, and the center span was 14.37 meters wide. So as we can see here, our engineering group can design, and our manufacturing team can supply a bridge plate which is suitable to fit a wide range of geometries and shapes. And using the survey data provided by the customer, a shape can be chosen which very closely matches the host structure. These 100-year-old arches will provide many more years of service life after being rehabilitated by bridge plate. As we saw in the earlier slides, this contractor also elected to slide the structure into the host arch using a steel angle at the footings. As mentioned previously, we can come up with some pretty unique shapes. This one is actually a reline in Thunder Bay, Ontario. The shape looks fairly triangular. During the construction, the tunnel liner was assembled in various sections at a nearby staging area and then lowered into place, and it was hauled through. And last but not least, to give you an idea of the total range of reline applications which are available from Armtec, we have here a small diameter pipe, which is being relined using a polymer laminate CSP pipe. You'll also notice, of course, we grout the annulus in these small structures as well. And that's it for me. Thanks, ladies and gentlemen. And now back to Janine.
Thank you, and thank you, Glenn. Thank you, Drew, for your presentation. And thank you, everybody, for joining today's webinar. We hope you enjoyed the presentation and found the information valuable. If you're interested in more details on these projects, we have the case studies available for the Terra Nova Reline Phase 1 and 2 on the Resource Center on your home page. Our question and answer period is coming, so please continue to submit your questions. First, I'll review a couple of housekeeping items. As you saw in the presentation, there are a lot of considerations for rehabilitation projects, and Armtec can help support you through the selection and design process. On today's webinar platform, your home screen, there are project inquiry forms available for download to get you started. Please feel free to contact us at any time for assistance. We hope that you enjoyed today's webinar and stick with us for upcoming events. Our next webinar is on the topic of mining solutions, highlighting considerations and products for site development. Stay tuned for an email with more details. To stay informed, please stay connected with us. You can follow us on social media, on Facebook, LinkedIn, and other platforms. At the end of this webinar, there will be a quick exit survey. So if you have any comments or would like to request a sales call, you can do so through the survey. We value your feedback and would like to know what you think of the event. You will need to allow a pop-up on your screen to get to the survey. Question 4 will ask you if you're interested in receiving more invitations from Armtec for events. Due to strict Canadian anti-spam legislation, we are required to have your consent to receive emails from us. So be sure you don't miss out on future webinars, and please make sure that you're on our mailing list. Please choose yes to consent on our exit survey. If you choose no, we'll miss you, and you will be permanently removed from all emails and webinar announcements. So please choose yes and stay close to us. So please continue entering questions and answers, and we will move on for a few questions. And let's see what we have here. Okay, so we've got a question. I think this was towards you, Drew. What would be the service life in a typical area for the tunnel liner plate system?
Sure. So, I mean, that would kind of depend on the type of material that we would supply the tunnel liner in. So it could be a galvanized system. Typically, generally speaking, the service life for galvanized steel is about 50 years or so. Again, that depends on the corrosion criteria, all those sort of things that we're designing for, abrasion levels in the stream. Aluminum tunnel liner typically in the range of 50 to 75 years, and then polymer coated steel, generally speaking, in the range of 75 to 100 years. So kind of a site-specific question, but we can design, if we know what those corrosion criteria are, if we know what the properties of that watercourse is, we can design based on AASHTO corrosion criteria for whatever service life is required.
Okay. How tight can the liner be to the existing culvert? This is also for you, Drew.
Yeah, that's a good question. Typically, what we recommend is having at minimum 50 millimeters between the new structure and the existing structure on all sides. We've done relines where it's less than that. Again, it's kind of a case-by-case basis depending on the state of the existing structure. Obviously, we need to design the liner to be able to accommodate the geometry with any deflections, throughout the whole length of the structure. So, we can get away with less if the existing structure has maintained its shape throughout its service life. I think we've done some relines with as little as 10 millimeters between the liner and the hose pipe. So it's kind of a case-by-case basis, but general rule of thumb is about 50 millimeters between the two structures.
Yeah. How durable is the polymer coating on the CAP product?
Fairly general question. I'll just say very. It's a very inert coating system, so it's actually an ethylene acrylic acid base, so it's not going to react with any chemicals. It's basically fine for virtually the full pH spectrum. As long as you're not having jet fuel going through the culvert, you should be good. So yeah, it's a very durable system, very abrasion resistant as well compared to, say, a galvanized coating. So if you have a fairly high energy stream with, as long as we don't have large boulders passing through there, the polymer coating will definitely be suitable in most applications.
What is it? Okay, so I'm going to interrupt the technical questions just because I'm seeing a lot of questions for how to get how to submit names of attendees for those who are attending as a group. So please provide your name, your title, and your email to drainage_webinar@armtec.com. And so, Glenn, I have a few questions for you here. Can the liner method be used for timber box culverts?
Yes. We've mostly used it for existing steel or concrete relines, but yeah, there's no reason why you wouldn't be able to use it for timber, an existing timber structure as well. Yeah.
Okay. Does Armtec provide stamped drawings?
Absolutely, yes. We have our own engineering group based out of Guelph, Ontario. Now I'll speak for myself. Randy McDonald, our engineering director, is actually licensed to practice in all of the provinces in Atlantic Canada, and of course he's licensed in Ontario as well. And I think you guys out there may even handle your own stamping process, I think.
Yeah, absolutely. So yeah, we can provide stamp drawings all across the country. So no matter where the project's located, that's absolutely feasible. Just to elaborate on that a little bit, just in terms of what we provide our seal for. So, we are designing these in a structural capacity. So of course we design it for the final installed condition with the fully grouted annulus for the given, live and dead load. So that's essentially what we stamp the drawings for.
Okay, we have time for one more question, and then for those on the line, if you still want to submit questions, feel free. We will respond to you by email. So last question, what is the impact of the grout on the environment if it gets into the water? Glenn?
I thought Glenn, you'd take that.
No, I'm honestly not sure. We'd have to check back into that. Janine, make a note of that, and we'll get back to that that question. I'd be interested in seeing that myself. I haven't had that asked before. Normally, when we grout these structures, the structure is completely dewatered, and during the installation of the grout, there would be no water flowing through the structure. And of course, then water would not be diverted back through the structure until all grout has completely set. So realistically, in a typical situation, there wouldn't be the opportunity for grout to actually drip into or seep into the flowing stream. But yeah, we can certainly dive into that one a little bit more to see on a just in case what would it be, for sure.
Okay. Well, thank you, Drew, and thank you, Glenn, and thank you, everybody, for attending and for your great questions. We will get back to you for sure. So stay tuned to our next webinar, and thanks for joining today.